So what we're going to do today is we're going to be talking about advanced averages, mixtures, and solutions. These are starting to show up on the GRE a lot more as the GRE is trying to make itself a little bit harder, and they're being successful with this. So what we're going to talk about today, a little welcomes and introductions. There's actually a very straightforward mixtures framework and a very similar, straightforward, easy, and very powerful solutions framework that we're going to go through. And then we'll do a little recap for you. I promise this is the least interesting slide that you have to sit through today. It's a little bit about me. So I've been coaching the GMAT and the GRE for over 10 years. Done it at UCLA. I've started my own company to do this. Sometimes the media asks me to talk about test prep and college admissions and admissions to business school and things like that. And so I chat with them sometimes too. Okay, let's get on to the main event here. So here's what we're going to cover today. We're going to talk about essential frameworks for mixtures and solutions, and we're also going to do a bunch of practice questions so you can see how this stuff actually is going to appear on the test and how you can actually use it. So here's the thing. You're going to get on the test something that sounds like this. Kathy's Candies sells chocolate creams and chocolate covered caramels. If the creams sell for $5 per pound and the caramels sell for $9 per pound, how many pounds of creams would be in a 10-pound mix that sells for $8 per pound? And there are probably some of you right now saying, well, Bruce, do I really need some sort of fancy kind of mixtures, kind of framework here? Can't I just put this into a regular old, kind of weighted average framework? And sure, you can, because we have all the elements. We know the total average price is $8, and we know the total number of pounds is 10. We know the price of creams is $5, and we know the price of caramels is $9. And the number of pounds of cream, well, that's X. That's what we're being asked for. And because we know the total number of pounds, we know the pounds of caramels we can express as 10 minus X. And I want to take just a second here and go over that because this is super important. It happens on the GRE all the time. The GRE is going to expect you to know that if A plus B equals total, so the number of pounds of creams plus the number of pounds of caramels is going to equal 10, then total minus A equals B. So the total number of creams, or 10 minus total number of creams, is going to be the number of caramels. And you know what? We can plug that right into the, to that weighted average formula that we all know and love. And it looks just like this. You can go ahead and solve that, right? You multiply everything through by 10. And if you do that, something very interesting and very useful happens. And it's this. Notice that for thing one, we have the value of thing one, $5, times the number of thing one, right? X. We have the same thing for two. We have the value of thing two, right? It's $9 a pound, plus the number of things, 10 minus X. And our target, we now have the same thing. We want an average of $8 per pound, and we want 10 total pounds. And that inversion of the weighted average framework that looks like this is super, super helpful, because what it does is it takes literally the way that they phrase things and the way that they ask things, and it goes very, very neatly into this framework. And when they start to take one or two steps kind of beyond to make things even trickier, this framework can handle kind of a variety of ways that they ask this thing. So it's simple and very powerful. And let's see how it would work in the Kathy's Candies example here. So we know that the value of the creams, $5 a pound. We know the caramels, $9 a pound. We know the total value that we're shooting for is $8 a pound. We also know the number of things we're going to have. We want 10 pounds after all said and done. We want 10 pounds of caramels. How many creams? Well, we don't know. That's X. And the value and the number of caramels has to be 10 minus X. The number of thing one plus the number of thing two always has to equal the number in the target. And at this point, it's pretty straightforward algebra. And you're going to find that X equals 2.5. Now, this works in a variety of situations. So let's say that they were to ask you This. Bruce's Awesome Coffee is making a new blend, which consists of premium Colombian and regular house. Premium Colombian costs $10 a pound. Regular house is $4 a pound. How much Colombian should the company use to make 100 pounds of a coffee blend that costs $5.50 per pound? Well, we're being asked how much Colombian. That's our X. We know the value of Colombian is $10. We know the value of house. That's $4 a pound. We know we're making 100 pounds of this stuff. So that's our target number. And we know the value. We want this stuff to average 5.5. We've got almost everything now. And we know house, the amount of house as well, because we know that the number of Colombian plus the number of house has to equal the total value number. So the amount of house, 100 minus X. And after that, it's just algebra. And we find that X equals 25. Let's say they try and make this even kind of harder to understand. The great thing is, no matter how they ask the question, we know for sure it has to fit into the framework. So the framework becomes a very powerful tool for us to sort their deliberately confusing words and get them into a simple equation that we can solve. So in the first part of a tournament, a card player won 60% of the games she played. During the rest of the tournament, she won 3 out of 20 games. If she won 40% of the games she played, how many games did she play in that tournament? Holy cow, that doesn't seem anything like the last one that we did, but it's in fact exactly like the last one we did. The value of part 1, she won 60%, 60 over 100. Value of part 2, she won 3 out of 20, 3 over 20. The target value, she's going to win 40% of the games she played. All right. We don't know how many games she won in the first part of the tournament, so we'll call that N. Part 2, we know for sure she played 20 games. And our target has to be the number of games, has to be the number of part 1 plus the number of part 2, N plus 20. Now we have a very simple equation that we can solve. And there are a lot of ways to go about solve this thing. I hate denominators, so I tend just to multiply the whole darn thing through by 100, solve down, and now we have N equals 25. And is that what we are being asked for? Think carefully. It's not. We need to know how many games did she play in the tournament. So we need the target number, which is N plus 20, 25 plus 20, boom, 45. So in each one of these questions, your job is simply to pick out the value of each thing and the number of each thing. And even when they try and make it look really, really kind of, strange and difficult, it'll always go into the framework. And that's the value of having a framework like this. Okay, let's take one more example here. The average mean of N test scores is 80. The average mean of the original N test scores plus an additional test score of 85 is 81. What is the value of N? What? Yeah, I don't understand what that means either, but I know that the original plus the added equals target, and we know we can just pick out the value and the number for each thing. So let's talk about original. Well, N number of scores, and we know what the average was. It was 80. What about the added? Well, we added an 85. How many 85s did we add to this thing? We just added 1. And what was the target? Well, it was 81. And how many total test scores are we going to have? Well, the N plus 1 is the total number of test scores we have, because the original number plus the added number always has to equal the target number. Now it's just math. And you find pretty quickly that N equals 4, and that is mixtures. Take it away, Nick.
Absolutely. I'm super excited to jump in here and share a little bit more about Bruce's upcoming GRE exam prep bootcamp. This is going to be an absolutely fantastic way for you to get even more of the expertise that you've just seen. We're just scratching the tip of the iceberg here. Bruce has 18 hours worth, or 12 sessions, 12 90-minute sessions of content for us that will walk you through every part of the GRE that you need to prepare to succeed on the exam. This is especially if you're on a budget or you're not sure exactly how to move forward in your GRE exam prep, this is exactly what you need to succeed. Not only do we have all of these live courses, all of these live sessions in the boot camp, but you'll also get all of the practice problems and curriculum that you need to go along with them, which are all created and curated by Bruce, who is, I dare say, our top expert on the GRE, on Leland. Has been doing this for decades, hundreds of successful clients. He won't tell you himself, so I'm here to tell it for him. He's absolutely fantastic, and so many folks just rave about him. You'll see reviews on his profile, which I'll send out afterwards here. But all that to say, there's so much value in the course. And Bruce, if you'll advance the slide, we have a little list here of everything that you'll get. The biggest is this 18 hours worth of live instruction with Bruce that will go a lot more deep and tactical even than this free event here tonight. You'll also get a community of others who are working towards this. Lots of study assignments. Again, all of the practice problems and practice tests that you'll need. Discounts on coaching, including working with Bruce and others one-on-one as needed, and access to our content library, Leland Plus. All of that normally would cost you over $6,000 if you were buying it in a one-on-one setting. But by doing this in the small cohort that we'll have in our GRE Prep Bootcamp, you'll get it for $11.99. And in fact, Bruce, if you could jump to the next slide here, we are giving a $400 discount off of that normal $11.99 price to anyone who signs up for the giveaway tonight. So if one of you, and it looks like we have 9 folks, you have a very high probability of winning this.
Probability is another lesson. We can do that one later. Yeah.
Sorry, yeah, Bruce, you're the probability master here, but highly recommend that you join this giveaway. I'll send the link again in the chat momentarily. But if you don't win, you'll get $400 off. Just a really great opportunity, and we'll announce the winner here shortly at the end of the event.
Thanks so much, Nick. All right. So back to our regularly scheduled kind of mixtures and solutions thing. Oh, one more thing I should add. You'll also get access literally to all of my material, all of it. So if you're like, oh, that pesky, interest rate formula, what was that? I've got all that, and I've got practice problems on that too. So you'll get everything in the course. So what we're going to do now is we're going to kind of we're going to continue this discussion about kind of like advanced weighted averages, and we're going to talk about solutions. And solutions, not surprisingly, work very much like mixtures, but with one added twist. So with solutions, what you get is you get a percent or a ratio times the number of things. Now, oftentimes on solutions, it's almost a little easier than mixtures because, oh, I know exactly what the value is. It's this percent or this ratio. So it can seem a little bit, and oftentimes it is, a little bit easier to pull out of the question. And let's take a look at a question, and we'll just kind of do the framework here. So how many gallons of a 10% antifreeze solution need to be added to 40 gallons of an 80% antifreeze solution to create a solution that's 50% antifreeze? Okay, so the first thing we're going to do is we're going to say, well, what is it that we're being asked? The other advantage of a framework, heck, they can only ask us 6 things. Right? That's it. Those are the only things they can ask. We're being asked how much added antifreeze we need to add to get to our target. Okay. So our original, if we read carefully, they start us out with 40 gallons of an 80% antifreeze solution. So the percent is 80 over 100. The amount is 40 gallons. We're adding a 10% solution. So 10 over 100. How much are we adding? I don't know. That's what we're being asked. And the target is a 50% antifreeze solution. So that's 50 over 100. And how much of this stuff are we going to end up with? Well, the original amount plus the added amount has to equal the target amount, just like in mixtures. So we have 40 plus X. And heck, at this point, all you're going to do is solve for X. Again, I'm a big guy for hating denominators, so I always multiply through by the common denominator. But there are lots and lots of different ways to work through the algebra. whatever is most comfortable for you. Just work through it. And I believe you're going to find that X is going to equal 30. Okay. So they can also ask you, they don't necessarily just have to ask you the amount that's added. Let's take a look at this question. What concentration should 4 quarts of salt water have so that when it's added to 5 quarts of a 40% salt water solution, the resulting solution has a salt water concentration of 33 1/3? Oh my gosh. I don't understand any of that, but you know what I understand for sure? The original plus the added has to equal the target, and they're only allowed to ask us one of 6 things. So what the heck are we being asked for in this? What concentration? We're being asked for the percent. We need the percent. What concentration should 4 quarts of salt water have? So then when it's added, we need the percent added. We need an X over 100. Okay, so we've got 4 quarts of this stuff for sure. We just don't know what the percent concentration is. They're starting us off with 5 quarts of a 40% solution. And our target here is 33 1/3% times 9, because we're going to have 5 plus 4 equals 9. So that's how much total, how many total quarts we're going to end up with. So lots and lots of ways to do the algebra. Again, I like to multiply through by 100 to get rid of those denominators. And you can just keep on moving through the algebra, and you're going to find that X is going to be 25. Okay. There's something very interesting that they can do, frankly, to you in this, and it has to do with how ratios work. So there's a very, very important thing here about ratios, and it's actually, while it can be sneaky, it's actually going to be a good friend, and this is why. So 1 ratio is actually 3 ratios, and it works like this. So let's say that in a certain pie contest, there were cherry and apple pies entered into the contest in the ratio of 3 cherry pies to every 5 apple pies. Now, it's entirely possible that there were 8 total pies entered into the contest. That means the ratio of cherry to total is 3/8. And that means the ratio of apple over total is 5/8. This only works with 2 variables, but when you're given 2 variables, when you're given 1 ratio, you're actually being given 3 ratios. Now that you know that, and you know that the test knows that, guess what they're going to do? They're going to start you out with that ratio, but in order to solve the problem, you're going to need that ratio. So they're going to expect you to be able to convert from thing A over thing B into thing A over total. Now, how do you know which ratio you need? Because I've made things more confusing. Now you got 3 ratios to choose from. Well, this is how it works. So let's go back to our antifreeze solution. And we had these ratios of an 80% antifreeze solution, right? What they started us with, that was 80 over 100. That's antifreeze over total. What did we add? We added a 10% antifreeze solution. That's 10 over 100. That's antifreeze over total. Our target was a 50% antifreeze solution. That's 50 over 100 antifreeze over total. So what you do is you figure out what the question is about. In this case, we're talking about antifreeze. That's what we're talking about. And the ratio that you set up is always antifreeze over total, or the thing that it's about over total. I know it's actually a little bit more complicated to explain than it is to actually do. So let's do one here. Okay. Well, the optimal blend of synthetic motor oil for a Formula One race car is a mix of monocarbonate and biglyceride in a ratio of 4:1. By the way, that's absolutely not true. I don't know what I'm talking about. But if the current engine contains 20 ounces of synthetic oil, that is 30% biglyceride, how many ounces of monocarbonate must be added to the engine to achieve an optimal blend? Dun, dun, dun. Okay, The first thing I want you guys to do is ask yourselves, well, what is this about? Is this about monocarbonate or is this about biglyceride? Usually the giveaway is what are you adding? And we're adding monocarbonate. This thing is about monocarbonate. So every single ratio needs to be monocarbonate over total. So we're being asked for how much of this monocarbonate we need to add. That's our X. So we're told that we have a blend of monocarbonate, bicarbonate in a 4-to-1 ratio, but that doesn't help us. Our target needs to be mono over total. Well, if mono over bi is 4-to-1, then mono over total must be 4/5. So that is our target percentage. Our original, well, we're told that we are starting out with bicarbonate over total of 30/100. That doesn't help us. We need everything by monocarbonate over our monoglyceride over total. That's 70/100. Everything has to be mono over total because this thing is about mono. So that's 7/10. How much of this stuff do we have at the beginning? 20 ounces. How much of this monocarbonate are we adding? We're not adding some watered down amount. We're like literally pouring a solution of 100% monocarbonate into the engine. So that's 100% or 1. How much of it are we putting in? That's what we're being asked for. That's X. And the target amount in the engine, it's always the amount of the original plus the amount of the added has to equal the target. So that's 20 plus X. So again, now we're in the world of doing algebra. So if we just crank through the algebra here, what you're going to find is X is going to equal 10. So the key is to understand what the heck the question is about. It's almost always what you're adding. So in this case, it's monocarbonate. And then you need every single ratio into what is it about over total. So we needed to convert every ratio, monocarbonate into total. And the reason we're able to do that is because one ratio is actually 3 ratios. Okay. We're going to do another ratio example. And oh, yeah, Nick.
I was going to say, we've got a question in the chat here from Harsha that I'll just voice over to you. Do GRE questions ever refer to ratios as fractions?
That's,
for example, 3/5 instead of 3/5?
Yeah, that's a great question. And how you want to think about fractions and ratios and percents on the GRE, there's no difference. They're actually exactly the same thing. A ratio and a ratio can be a fraction. A ratio can also be turned into a percent. They are, in fact, exactly the same thing. Does that help? All right. And here's the other thing. The truth is on the GRE, it's a really good question because we actually love ratios on the GRE. And part of it is as soon as they give you a ratio, they can't help but give you so much information. They give you one ratio, they just gave you 3 ratios. They can't help but do that. The other thing that we love is when we're being asked back for a ratio, we actually don't have to worry about getting an exact value for each thing. And that puts us at a huge advantage when we solve it. Even though these things look ugly, they're easier. And here's a great example of that. So a scientist needs to create a solution that's 40% of component A. Unfortunately, the lab only has a bottle of 20% component A solution and a bottle of 50% component A solution. In order to create a 40% solution, what percent of the total solution would need to be a 20% solution? And boy, is that confusing. Part of the reason that it's confusing is they don't even do us the courtesy of assigning variables. We're going to need to do it ourselves. So we're going to do this really quick. So we know that we can set up the framework here, right? And we're going to call X, well, that's the amount of 20% solution. We're going to call Y, well, that's the amount of 50% solution. And what are we being asked for here? What's the ask? what percent of the total solution would need to be the 20% solution? Okay, what exactly does that mean? What they're asking for is what percent of the total is the 20% solution? Or in math, what you just been asked for, X over total, the amount of 20% solution as a part of the entire thing. We have just been asked back for a ratio, and we love that because we don't have to worry about trying to just express things in one variable. Look what we get to do here. We get to say, well, what's the value of the 20% solution? Yeah, well, that's 20%. How much of that stuff do we have? Well, we got X. What about the Y solution? Well, Y solution, that is the 50% solution. And then how much of that do we have? We don't have to get fancy. We got Y amount of it. So how much of our target? Well, we know we're shooting for a 40% target solution. And we know for sure that the amount of thing one plus the amount of thing two has to be the amount of our target. So we got X plus Y. And you're thinking to yourselves right now, Bruce, that's one equation and two unknowns. There's absolutely no way we can get a value for X and Y. And you're absolutely right. We don't need a value for X and Y because we know that one ratio is really three ratios. And it's going to work like this. So 0.2X plus 0.5Y has to equal 0.4X plus 0.4Y, right? Just multiply 0.4 through the parentheses. And what do we get? 0.1Y equals 0.2X. And guess what that is? This is another way to write a ratio. That's X over Y is 1 over 2. If you wanted to say X over Y equals 0.1 over 0.2, that's absolutely right. But, we can write it as 1 over 2. That is fine. We can multiply top and bottom by 10. So at this point, if X over Y is 1 over 2, X over total must be 1 over 3. Boom. That easy. We didn't have to get a value for X and a value for Y because we were being asked back for a ratio. And that is so convenient. That's why a number of reasons why we love ratios, but we love ratios for that. Okay. And that's, of course, 33.3%. Okay. And that is mixtures and solutions, everyone. I hope it was very helpful. Those frameworks, super easy to use. They lie right on top of how they ask these questions. So if you pull out the frameworks, the chances of you getting these questions right and getting them right fast are very, very high. Thanks for spending some time with me. I can send it over to Nick because he's got some exciting stuff.
Absolutely. I'm excited to announce that our giveaway winner is, drumroll please, Payush, so excited for you and so glad you won the giveaway. So great to have everyone on the event tonight. Again, if you didn't win the giveaway, we would still love to have you in the boot camp. Fabulous value. Such a great way to get all the way through your GRE exam prep in one sitting with this amazing host here, Bruce. Thank you so much for an awesome event, Bruce. And we'll all be sending out info on the boot camp to all of you here shortly. But Payush, congrats on winning the seat that we're giving out tonight. And everyone else would love to see you along with Payush here at our GRE exam boot camp starting in January.
All right. Hey, and if you want to work with me, I do have the you can work with me on one-on-one. It's a lot less expensive to work with me through a boot camp if you want to do that. But some people want one-on-one coaching, and I'd be happy to do that for you as well. Okay. That's what we've got. Thanks for spending some time with me and doing the and doing mixtures and solutions with me today. And hope to see you guys in the boot camp. See ya.